this question, iodine atoms combine to form molecular iodine in the gas phase. Given to you the equation I gas plus I gas produce I2 gas. The rate constant for the above reaction is 7 times 10 to the power of 9 m to the power of minus 1 s to the power of minus 1. If the initial concentration of iodine atoms is 0.086 molar, calculate the concentration after 2 minutes. And the second question asks you to calculate the half-life given the initial concentration. Alright. In this question, the information given is the value of K. Okay, from this value of K, we can determine the order of reaction based on the unit of K here, which is referred to second order. 1 over A minus 1 over A naught equal to KT. Concentration A, you have to substitute with the compound involved in the reaction. So this 1 over I minus 1 over I naught equal to KT. Okay. From the question given to you initial concentration, so we can substitute into this value. And the question also give you the time at 2 minutes. Okay, but referring to our K unit, the unit is per molar per second. So the unit for time that we have to use is also in second. This is the one that we are going to find. We substitute into the formula. Minus 1 over 0.086 equal to K here is 7.0 times 10 to the power of 9 times 2 times 60. Okay, and by performing this calculation, you will get concentration of I is 1.2 times 10 to the power of negative 12 molar. So this is the concentration that left after 2 minutes. Okay, we continue with part B. The question asks you to calculate the half-life. Okay, the half. This is the symbol of half-life of iodine atom if the initial concentration is 0.42 molar. So we know that it is second order. So we already have the formula of T half for second order, which is 1 over K I naught. We already have all of the information given. 1 over K is 7 times 10 to the power of 9 times 0.42. So we will get our T half here is 2.4 times 10 to the power of negative 10 seconds. Don't forget to put the unit for the time, and as a unit is compulsory for you to get your mark. And for the part 2, you can calculate it yourself as it is also used the same way as part 1. Let's go to the next question. The data listed indicated below were obtained from the radioactive decay of magnesium. So given to you the table involve time and molarity of magnesium by graphical method. Prove that this decomposition is first order. So when the question asks you to use the graphical method, means you have to plot a graph on the graph paper. Okay. In this question, it is not stated for you to use either half-life method or linear graph method. So you can choose either one. In this question, I want to use linear graph method. As it already mentioned, it is first order reaction. Okay. So for the first order reaction, I will plot graph ln Mg versus T. Why I will use this graph? Okay, when you want to use the linear graph method, we have to refer to our integrated rate law. So for our first order, it is ln A naught minus ln AT equal to KT. So we will plot graph ln AT versus T. This will be our Y. This will be our X. This will be M. This will be C. Okay, relate with the linear graph equation. Okay, so to plot graph ln magnesium versus T, I have to create a new table or new data so that I will have the value of ln ng. So first thing I will calculate the value of ln ng. Okay, so by using calculator, you calculate this value of ln magnesium because you are going to plot graph of ln magnesium versus K. Okay, so I want to show you the graph that I already plot. Okay, so I calculate the ln ng, okay, and I plot based on the time, so I will get a straight line. Okay, so it is proof that the reaction is first order. What happens if I don't get the straight line for this graph? Means that reaction is not first order. It might be zero order or second order. But for this graph, I get that straight line. So after I plot the graph with correct axis with straight line, so I have to state that I have to give this confirmation, straight line, proof that the reaction is first order reaction. Because the question asks you to prove, right? Okay, the second question asks you to determine the rate constant. Rate constant K, if we look at the relationship that I already write here, where is K? Here is K, right? Okay, so K is equal to our M. So, as it is negative slope, okay, so we have to calculate the slope for this graph. Okay, so you have to show on your graph that you calculate the slope for this graph. So, by using the way to calculate slope, so I get this value. This will be our K. Okay, so the slope is equal to our rate constant. Look at the unit here, per hour. Why I use per hour? Because from the question, using hour as time. Okay. Next question asks you to determine the half-life if A not equal to 1. Okay, so as we already know, it is first order and we already have the K value, so we can calculate our T half by using the formula ln 2 over K. Ln 2 over K is the formula of half-life of first order reaction. So just substitute into the formula, so we will get this value. Okay, so this is how to solve the question involving the linear graph method. This is the last question for this session. The experimental data for the decomposition of N2O5 gas at 25 degrees Celsius are shown in table. Plot a graph of concentration N2O5 against time. From the graph, determine the half-life of the reaction, calculate the rate constant of the reaction. So in this question, already asked you to plot graph N2O5 against time. We already have the concentration N2O5 and we already have time, so just plot on the graph paper. Okay, this is the one that I get. At our y-axis is our concentration and the x-axis is time. Okay, so look at here. So when I plot graph concentration against time, I get a curve. So it shows that this order might be first or second order. So how do I know it is first or second order? Look at our half-life. Okay, we will look at our first T half and second T half. Right. So we know that our initial concentration is here, which is 0.2. Okay. At T0, concentration is 0.2, means our A naught, this is our A naught, or N2O5 naught is 0.2. When it becomes half, it will become 0.1. This is A naught over 2. So we get 0.1. So from the graph, I will find out what will be our first T half. So from your graph, okay, this is our first T half, 50. The value here is x equal to 50. And the second T half is when it becomes half from first t half. So first t half is 0.1. So we get here 0.1 over 2 divided by 2, we get this one. So this is the value of t half second. What will be the t half second is this range. Okay, so 150 minus 50, we get 100. So we can have the value second t half equal to 2 times first t half. Okay, this proves that this graph is second order. Is second order. So the question asks you to calculate the half-life, so we already get the half-life. Rate constant of the ratio. Okay, for this graph, okay, we know that it is second order, and we already calculate the t half, so we can use our t half equation for us to find out the value of rate constant. So for the second order, this is the formula of half-life. We just substitute the value 50 seconds here. This is our t half. 1 over k a naught. A naught here is 0.2. Perform this calculation, we will get k equal to 0.1 per molar per second. Don't forget the unit. We know that it is second order, so the unit must be per molar per second. So that's all for this session. Hopefully you will understand all the contents in this video. If you have any question, you may ask me. You may leave your comment in the video, or you may ask your lecturer to get further explanation. Okay, thank you.